Okay, we introduced packages and we talked a little bit about NumPy or NumPy, whatever you want to call it. And we're going to add on to this discussion of NumPy. Now, one of the good things about Python is a lot of these packages have very well-defined user manuals. So if you're ever trying to figure out what you need to do, you can simply look at the user manual and find out what you have to do as an absolute beginner. So NumPy Python is what we'll search for, and here it is, numpy.org. And so this is everything you need to know about this particular package. You want to figure out how to install it. Here's all the code to install it. Right? You want to look at the documentation. Here's the user manual. You want to look at the user guide? Look at the user guide. What is NumPy? Installation, quick start for absolute beginners, fundamentals, and I think you should kind of look at this stuff as you're learning how to do any of this. Because guess what? This is exactly what I've been reading to be able to move from my understanding of R programming to Python programming. So if this is the way I learned it, I think you can learn it this way too. So I strongly recommend looking at numpy.org and learning more about this particular package. So let's get an understanding, and I'll talk to you about my understanding of what this is. So this is NumPy array package. And NumPy arrays fit most data better than creating lists or dictionaries. An array could have multiple observations. Across multiple variables. What we're going to do is we're going to start by creating some arrays, and then we're going to work towards reading in arrays. And the arrays we're going to work in probably won't be able to be used by NumPy, because one of the things about NumPy arrays is they can only be numbers. The arrays that you mostly work with are not just numbers. There may be text, there may be symbols in there. And the NumPy package is not going to be the package you want to use. So while a Python list, going back to why this is different, why a Python list can contain different data types within a single list, all of the elements in a NumPy array should be homogeneous. The mathematical operations that are meant to be performed on arrays would be extremely inefficient if the arrays weren't homogeneous. NumPy arrays are faster and more compact than Python lists or dictionaries. An array can also consume less memory. And is pretty convenient to use. So it also stores, it uses much less memory to store the data. And it provides a mechanism for specifying the data types. We'll show some examples. Now this allows the code to be optimized, to make it go faster. Okay, so as we do with any of these packages, we've got to import it. And we're going to import it as NP because that's all of my code. Whenever I'm using NumPy, it's all NP. So the first thing we're going to do is we're going to create a one-dimensional array, right? When we introduce packages, I created two-dimensional arrays. Well, let's start simple. Let's just create a single one-dimensional array. So we're going to name this array A, and it's going to be NP array, and it's a function. And to define the array, everything goes in brackets. So we're going to define this as 56, 75, 23, 87, 134, and 431, right? And we're going to run, this is in my, I'm going to put this down here. So here we're going to create a one-dimensional array and determine its shape. All right, so let's read in the array. We're looking at variable view here. And when I'm looking at variable view, I can determine what its shape is. Whoops, NP is not defined. Do you see that? Why? Because I haven't run this code first. Now I can run this and it will work. Beautiful. So what this is it's a 6 by nothing array, right? Another way of looking at this is I can go a.shape and I can run what is the shape of the array. And it's a 6 by no columns. It's just a string of 6 numbers. So one-dimensional arrays, the way to interpret this, are interpreted as a single variable with X number of observations. And it's very similar to a list. A two-dimensional array have rows and columns, right? And in most business data, you're going to be dealing with two-dimensional arrays, rows and columns. Have you ever seen anything that's got anything that's a 3-dimension or multiple dimensions beyond 2? Generally not. So let's focus our attention on two-dimensional arrays. And these can be created directly, or you can convert lists into an array. So let's try and create a two-dimensional array. We did this before in the previous video, but let's do it with this now. So we're going to call this array B, and we're going to call it np.array, and parentheses. That's the whole array, and then another bracket inside is going to be the first row of the array. So in this one, I'm going to call it 58, 84, 90, 200, and 130. Comma, I'm going to put it in another row. And it needs to be in square brackets, 84, 90, 22, 1, and 45. All right, so I'm going to run this line. We'll see what up here, what it looks like. So let's run this. And now we have an array. It's a 2 by 5, right? And so I also know that the shape is a 2 by 5. So I can go in here and put B shape and run this. And it's going to say you got a 2 by 5. But I don't really need to be, I can get a lot of information here in variable view. I don't need to be running B shape. But I just want to show you that you can. All right, let's create a list, right? And it's going to be a list of 3 lists, if that makes any sense. So let's create a list. Equals, and I'm going to put a bracket, and in this I'm going to have a list within a list. So the first list is going to have 50, 84, 90, 200, 130, and the next list I'm going to put in here has got 84, 90, 22, 1, and 45. I'm going to put another one in here. And I'm going to create another list within the list. So I've got a list of 3 things, and it's 62, 90, 75, 45, and 22. All right, so let's run this list. And what we'll see here is list is a list of 3 things, a list of 3 lists. There we go. Here's my list. It's got 3 separate lists within the list. Now I can convert all of these lists by putting it into an array. So we got C equals np.array, and all I'm going to do is I'm going to just take list and I'm going to have it convert it to an array. Okay, so we're going to take list. I've defined list here. I'm putting list in here. There's the function array, so it's NumPy array.array, and I'm going to run this line. And so now what I've got is C is an array, which is now a 3 by 5. 3 columns, 3 rows, 5 columns. All right? You can also use arrays. You can also create a range, if you want, of data. So let's create some arrays. So I'll type in what I'm doing here. You can also create arrays using a range. It's not a range, it's a range function. Okay? So the following are one-dimensional arrays. All right? So we're going to go D, just kind of going along what we've got here. And what I'm going to do is I'm going to say, okay, I want a NumPy array, a range, and 10. Okay, so let's run that. And what it's giving me is it's giving me a list of numbers from 0 to 9. All right, so that's all that did. If I wanted to, and I can see what it is up here. Let's try another one, E. and we're going to do np.arrange, and I want to go from 2 to 10, and I want to put in the data type. Data type equals float, right? And there's lots of different data types that are out there. Let's see what E looks like when I run this. So E, right, where all my other arrays have been integers, now this is a float, and you can see each one has 2 point, 3 point, 4 point, etc., etc. And it goes from 2 to 9, right? It goes up to 10. It doesn't go all the way, but it starts at 2 and it stops before 10. All right. How about another array where I'm actually going by a different increment? So let's call this one F, np.arrange. We're going to start at 2. We're going to go to 3. Well, this will give me one number, but I want to go up by 0.1. So this is going to say I'm going to create a range of numbers from 2 up to 3, but not including 3. And let's run that. And that's what I've got. So I've got from 2, 2.1, 2.2, 3, 4, 5, 6, 7, 8, 9, but we're up to 3, right? 3 is the last one. And so that's how many numbers. So I've been able to create this one-dimensional array using these different methods, right? So if you look at it and say, okay, if I just put in 10, it's going to give me 10 numbers. If I give it a starting point and an ending point, it's going to give me the numbers at the starting point up to 10. And I can define what the data type is. And then if I want to add a third element, I can also say I want to increase by 0.1, 0.5, 10, 20, right? So there's a lot of different ways you can create these different arrays. You can also create random numbers in the array. So the random method of the results of default RNG will create an array filled with random values between 0 and 1. It is included with the NumPy .random library. Below are two arrays created with shapes 2 by 3 and 2 by 3 by 2. So it's a 3-dimensional array. And just this mostly for illustration purposes. I don't think you're going to be working with any kinds of weird arrays that are 3-dimensional. We're going to set the random seed to 42 so that you can reproduce these pseudo-random numbers. Right? Because if you always start with if you always start with the same random seed, you're always going to get the same set of numbers, right? So it's not really, we're not really random. All right, so we need to import from the NumPy random. So we're going to call from numpy.random import default RNG. Okay, so I'm just going to bring that in, right? Okay, So now we can create these random arrays. So we'll call the next one, so we get EFG equals default RNG, and the random start is 42, dot random 2 by 3. Okay, so let's run G and let's see what we get here. All right, so what we've got here is we've got a 2 by 3 array, and you can see all these numbers are all between 0 and 1. All right, and we've got a 2 rows, 3 columns. All right, so now we can do the exact same thing, right? And if you wanted to, I mean, these aren't really useful numbers. What we could do is we could just take these and round them and multiply by 100 and round them, and then we'll have integers, right? We'll have random integers, right? And we'll kind of create that later. So these arrays are just doing zeros and basically zeros and ones, right? Okay, let's create a 2 by 3 by 2. All right, so let's create H equals default RNG. And again, the random seed is 42. Point random. And we want this to be a 2 by 3 by 2. All right, let's run that. And here you go. Here's our 2 by 3 by 2 array. So 0.73, right? You have to, it doesn't give you everything in there, but it's just because it's two 2 by 3 arrays on top of each other. So that's what the other dimension is. And again, we can, and we'll do this with the G1. We can, if we wanted to get whole numbers, let's take G is going to equal G times 100. All right, so it's going to take all of our G1s that we can see all these here, and it's going to multiply every single element by 100. So now you can see it's 77, 48, etc. And I'm also going to round. So we'll go G dot round, and I'll just put that there, and this should change the way we see this array here. So let's see. Oh, just going to show it here. If I wanted to define it and redefine it, so right now the main numbers are still there. If I wanted to redefine it, I would have to G is equal to G dot round like that, and then we'll see the array become different up here in my variable view. Now I've got random numbers, granted not really random, starting with 42. And do the same thing with any of these things. You can always redefine them. Right? So one last thing on NumPy arrays. If you have a missing value in your array, or using something other than a number, NumPy will coerce the array to be a specific data type. Okay, we're going to not do a lot of stuff with NumPy, but I just want you to at least get this kind of introduction on basic looking at different kinds of arrays and getting an understanding about row, column. Here it's row, column, and then two sets of arrays, two sets of 2 by 3 arrays.